Welcome to my channel Content Hub. Today I am going to explain about the double hashing. Double hashing is also collision resolution technique, and the name is saying the double. Double, it means that there are two hash function is going to use here to calculate the index if collision occur. Now I will tell you that how the two hash function is going to use to calculate the index of an element if collision occur. So here I have given that condition that if no collision occur, and how we'll say that no collision? If the two element will not going to get same index, that's called no collision, and if two element will get same index, that's called the collision. So here suppose I got some element 10 and that index is getting 0. In that starting time the hash table was empty, then you can easily store, and that's called no collision. So if it is no collision, simply you use hash function and calculate the index and store in the hash table. If the collision occur, here if no collision occur, you can simply you do. If the collision occur, suppose there is a two element getting same index, then how will you store two element in the hash table? That's not possible, because in the single chair we cannot sit two person. In single chair two student will not going to sit. So for that reason how to resolve that problem? Using the double hashing. So double hashing is saying that they have a two hash function. They say that use the both function. First calculate index using the first hash function. Then what will you do? Then again calculate the second index with I, and then sum this both value and then modulus with the table size. So use this formula to calculate the new index of a element if collision occur. If not occur, then simply if collision occur, do apply this formula and then calculate the index of the element. Now I have taken one example for the better understanding, and I am going to use here double hashing if collision occur, and here I also said that we'll apply the division method. So I am going to use here division method for calculating the index. And one more thing is there, here look at that, here they have given two hash function. Here they have given two hash function. Why so? Because we were learning here double hashing. So here they have given double hash. So using first h1 it means that using that this is the first index, first hash function. Using first hash function, you calculate the index of a given element. So given element is 3, and if I am going to calculate index of a 3 using first hash function, I'll get 9. Now check the hash table. Is hash table is empty? Is hash table 9th index is free? Yes, 9th index is free. So the 3 is going to store at 9th index. 3 is going to store at 9th index. Now my second element is 2. If I am going to calculate the index using first hash function, look at that, I am using first hash function. So if I am going to calculate index of the 2, then I'll get the index value is 7. Now I will check the hash table. Is 7th index is free? Yes, my 7th index is free. So my 2 is going to store at 7th index. 2 is going to store at 7th index. Next element is 9. Using first hash function, I'll calculate the index. And one more thing is that you are getting in a single time, you are getting the place in a single time, then the number of probe is 1. The number of probe is 1. So now I am going to use calculate the index of the 9, and using the first hash function, we'll get the index is 1. Check that first index of the hash table is free. Yes, this is free. Then what will you do? Store the 9 at first index. Right? So you are getting in a single time. So number of probe is how many? Number of probe is 1. Now my next element is 6, and using first hash function, you calculate the index, you will get the value is 5. Now check your table. Is 5th index free? Yes, this is free. So far see, I haven't used hash 2. Why so? Because no collision occur. So I haven't used H2. right? So here you check that fifth index is free. Yes, fifth index is free. So what it will do? The 6 is going to store at fifth index. 6 is going to store at fifth index. Now coming to the 11, then 11 came. 11 came, then what will you do? If 11 came, if you are going to calculate the index, same process you follow. First calculate the index using the first hash function. If you calculate using first hash function, you will get the index value is 5. You will get the index value is 5. Now check the table. Is fifth index is free? No, this is not free. Then this is called, this situation is called what? This situation is called collision. The 6 is already stored at fifth location, so 11 is not going to store there because that is filled already. Now perform the double hashing. Now use the second hash. Now the second hash function plays their role. So now using the second hash function, calculate the value. Then what will you do? Now first you have to calculate the value using the second hash function. So first using first hash function you are getting value 5, and using second hash function you are getting value what? 4. Now do what? You have to also use the I. You have to multiply with I. So what I am doing here? My first hash function value is 5, second hash function value is 4, and 4 into 0. Why I am saying that 0? Because this is I value, and I is start from 0 to m minus 1. So I is here 0. So if we calculate 5 plus 4 into 0 and then modulus table side, you will get again 5. So this is not filled, and this is called one probe. This is one probe. Now I will going to increment by 1. So first hash function 5, second hash function 4, and into 1 because I is incremented. And if you do that, then you will get that 9, and check that hash table. 9th index is free. No, 9th index is not free. So this is called second probe. This is second probe. Now I is incremented by 1. Now I became 2, and if you calculate the index, new index, then is 3. You will get the 3. Check that is third index is free. Yes, third index is free. So 11 is going to store at third index. So 11 is going to store at third index, and this probe is called 3 probe. So we can say that while inserting the element 11, you got 3 probes. So number of probe of 11 is 3. My next element is 13. My next element is 13. Using the first hash function, I calculated index value is 9. Using second hash function, I calculated value is 0. Now what will you going to do here? Collision occur because 9 is not free. Go and check the hash table. Is 9th is free? No, not free. It means collision occur. Now apply the double hashing. So if you apply the double hashing, then what will you do? First hash function, then second hash function, then multiply with I value. So your I value. So you are getting second index is second hash function value is 0. So if it is your second hash function is 0, because what's your formula is saying that first hash function plus second hash function into I. If you are getting second hash function is 0, now tell me whatever the I value will come, you always get 0. So every time you will get the index value 9, and that is not free. Look at that, it's very much important. See, even you I incremented, previously you put it that 0, now I has become 1, and 1 into 0, again 0, then again you will get 9. Then similar like that you will increment I value is 1 to 2. Then again you will get that 9 only. So every time you are going to get that 9, 9, 9 like that. So you will not going to store 13 because it's not possible, because every time even you are using the second hash function, still you are getting the same index. So that's not free. So because of that reason, this 13 is not going to store in the hash table. That's the reason I have written that what? Not inserted. 13 is not going to store in the hash table because always you are getting 9th index. Right? Next element is the 7. 7 again, go and check the hash table. Is 7 is free? No, not free. Collision occur. Now using the second hash function, calculate the value and do what? you will check that 7 plus 7 is first index, 2 is the second index, and now you multiply with the I value. I is 0, and if you calculate you will get the 7. This is not free. 7, you check that 7 not free. Then I is incremented by 1. Then you calculate, you will get that 9. You check that is 9 free. No, 9 is not free. Then again you calculate, I is incremented by 1. Then you will get that 1. Go check that is 1 free. No, it's not free. Then again what will you do? I is incremented by 1, 3. You will get the index is 3. Check that is 3 free, not free. Then calculate what? I is incremented by 1. It became 4. Then if you do that, if you calculate that, you will get index is 5. Right? So guys, one more thing here. Try to observe here. So you incremented I value 0, 1, 2, 3, 4. Till 4. You are getting value what? 7, 9, 1, 3, 5. Right? Now your I is incremented by 1. You got that value is what? 5. Using this value, you calculate the index, you will get value is 7. Right? 7, check that's free, not free. Then I increment by 1, 6 you got that. At 6, you are getting what value? 9. 9 is free, no, not free. So look at that, try to observe that upper part. First you are getting 7, 9, 1, 3, 5. Then again started 9, 7, 9, 1, 5. Means it's forming the cycle. And one more thing, you have to stop where? I value is going to stop at 0 to 9 because your table size is 10. So you will going to stop at 9. Right? So this 7 is also not going to store in your hash table. Right? Because you are not getting a place in your hash table that is free, there you are going to store the 7. Either you are applying the double hashing technique. Right? Now your next element is 12. If you are going to store the 12, using the first hash function, you will get index 7. Go and check that your hash table. Is 7th index is free? No, this is not free. Then using the second hash, calculate the value. Then after what will you do? You check that first hash function, second hash function into I value, and then you calculate the index, you will get 7. That's not free. Then I is incremented by 1. 7 plus 7 into 1 modulus 10. You will get value is what? 4. Go and check that is 4th index is free. Yes, this is free. So 12 is going to store at 4th index. Right? Understood? This is the double hashing. And if you want to write the order of the hash table, what will you get that? Empty 9, empty 11, 12, 6, empty 2, empty 3. So this will be the order of a hash table, order of an element in the hash table. Okay. Next thing is very much important. Just now I have explained the example. In that example, what happens? The sum of the element is not getting the chance to insert in the table, and that was the problem. Why? Because of that was the not good way to select the second hash function. So for that reason, there is another way is also of selection of the second hash function. Suppose there is a hash function given, you follow that. If there is a 2 hash function is already given, follow that one. But some case happen is that the second hash function is not given. If second hash function is not given, then what will you do? And that's the better way, you can say that that's the good. This is the good way of selection of the second hash function. So you can reduce the more number of collision. Means you will reduce the number of collision. Then how will you select the second hash function? They will give you the first hash function. They will give you first hash function. But what about the second hash function? So this is another method here. I have written that to select the second hash function, that will help you to reduce the secondary clustering. That I am going to explain the secondary clustering, and also you can say that to reduce the number of collision and give the chance of element to store in the hash table. So how will you select the second hash function? So for that reason, See that for first hash function, simply you do the key modulus table size. Suppose they have already given key modulus table size, they have already given. But how will you calculate, how will you select the second hash function? For that reason, what will you do? Prime minus key modulus prime. Prime minus key modulus prime. Now the question arises here, what is prime? Now the question arises here, what is prime and what prime value will you take? So prime is nothing but a number that is only divisible by 1 or themselves. 1 or themselves only. So that number is called prime number. And one more thing is saying that what prime number will you take? So it is also saying that the prime is a prime smaller than table size. So you will take the immediate smaller prime value of a table size. So suppose here your table size is given that 13. Here given that your table size is 13. So what is the immediate smaller prime? What is the immediate smaller prime? 12. 12 is not the prime because it's divisible by 4, 3, 6. 11 is the prime. Yes, 11 is the prime. Yes, 11 is the prime. You can take that a smaller prime is 11. Yeah. You can, here you can take that, they are saying that a smaller prime, you can also take that 11. You can also take that 11 and do solve that. So here simply they are saying that, here they are not saying that the immediate, oh sorry I have mentioned that, but you can take that a smaller prime, either you can take that a smaller, they are saying that a smaller you take that. So you can also take the 7 and you can also take that 11 also. 11 is also the prime value, so you can also take that 11 minus key modulus 11, that's also the one type of the prime, and that also going to help you to calculate the hash 2 functions, right? Then I have taken here in this example I have taken prime value is 7. It's your wish, if you want to take 11 you can take it that. So just do remember the prime value is always smaller than table size, and either that prime value, either you take 7 or either you take 11, either you take the 3 is also the one prime number, and 5 is also the prime number. So it's your wish what prime number you want to take it, right? So here I am taking that prime value is 7, and on that basis I am calculating the second hash function. So here I have given element is in this example given element is 19, 27, 36 and 10. Now I am going to calculate the index using the first hash function of a 19. So here I have already calculated 19 modulus 13. I'll get the index value is 6, and suppose in my starting in my table was completely empty. So this 19 is going to store at 6th index. 27, if I'll calculate 27 modulus 13, that value will get that 1. So that 13 is also going to store. Suppose suppose I am taking that this is my 6th index. So 19 is going to store here, and similar like here 27 come and their index is 1. So 27 is stored somewhere like here. And next one is 36 modulus 13 I'll be get that index value is 10. And in starting, see recently only 6 and 1 is 9 and 27 is started, so there is no collision. 36 kept, their index is also 10. Now 10 come and 10 modulus 13 I'll do again 10 coming. So now look at here, this two element 36 and 10 both is getting same index. It means that collision occur. Now what will you do? So what I have said that to calculating the second index, for calculating the second index, what will you do? First, what will you do? The prime minus, so what will be the second hash function? Prime minus key value is what? 10 modulus prime value. So here I am taking prime is 7. So 7 minus 10 modulus 7 equal to, if you do calculate, you will get the 4. You will do calculate, you will get the 4, and check the table is 4th index. Sorry, no. This is just the second index. This is 10 is first index and 4 is the second index. Now apply the double hashing. In double hashing, what we are doing? First index plus second index into I. Right? So what is your first index? First index is 10 plus Second index is what? 4 into I value. I is assumed that 1 value I am taking that. I is 0. If I take that, you will get the same answer. Then I am taking that 1 and modulus table size. If I do that, we'll get the value is what? We'll get the value here. If we do that, we'll get the value is, total value is 5. And now check that, so far you haven't got the 5 index, so because of that reason now it's free, 5th index is free, so 10 is going to store at 5th index. So what will be the order? You will get that order. What is the order? You are getting that 19 at 6th index, 27 at 1st index, 36 at 10th index, or 10 is going to store at where? 5th index. Understood? So guys, I have done one mistake here. I said that immediate prime, immediate smaller prime. No, it's not concept like that. You will take that smaller prime, that will be your wish, what prime number you want to select it, that you can select it. Okay, accordingly you can calculate the second index, calculate the new index of the element. That's next I am going to explain about the advantage and disadvantage of the double hashing. So what is the advantage? Advantage is that no extra space, because you are calculating the new index using the double hashing and you are utilizing the space. So here this is the advantage. And in double hashing, primary clustering problem also resolved, and also secondary clustering problem is also resolved because of that second hash function. So this secondary clustering problem is resolved because of second hash function, because here you are using two hash function, so that will help you to reduce the number of reduce the secondary clustering problem. And disadvantage of the double hashing is that the worst case time complexity in the searching the element, it will take order of n, because hashing is taking order of one time, constant time, but worst case time is here is taking order of n time. So because of that reason, this is the disadvantage. That's all about the double hashing. Thank you for watching my video.